Hi again. In this video I want to continue talking about area, but this time I want to talk about area of triangles. Now I've started off with my 5x4 rectangle that I had in the previous slides. What I want to do now is I'm going to show you how we come up with the area formula for a triangle. Basically, if I take this rectangle, now I've tried to draw it as accurately as possible because what I'm about to show you requires some accuracy, but what I'm going to do is I'm going to take my rectangle and I'm going to cut it in half across the diagonal like this. Okay, and what we end up with here is two triangles. Okay, so if we know rectangles or squares, we know that if we cut them in half across the diagonal, they are going to create two triangles. Now, theoretically, if we think about this, when we have an area of a rectangle, which is a length times a width, if we take that area, which was the area of my total purple triangle, rectangle, that was a 5x4 rectangle, that's going to give me an area of 20 centimeters squared. Okay, so this purple rectangle, has got an area of 20 centimeters squared. Now, if I've divided that by drawing that line across the diagonal, if I've divided it into two even triangles, basically what I've done with my 20 centimeters squared is I've cut it in half. Okay, so I've essentially just divided it into those two triangles. So what I'm going to get at the end, when I've cut that in half, is I'll end up with 10 centimeters squared. Now there is a way that I can check to see whether this is actually correct or not, to see whether each one of these triangles does actually equal 10 centimeters squared. And the way I can do it is the same way that I showed you how to work out the area of a rectangle, and that is by counting the squares. Okay, so we can count all of these squares. It's just a little bit more difficult with a triangle because you've got all of these part squares, and this is the reason why I needed to draw this as accurately as possible. So I'm hoping, fingers crossed, that this actually works. So what I'm going to do is I'm going to start by colouring in the full squares. So I'm going to do that in pink. So I'm going to colour in all of the squares that are full squares that haven't been cut through by that diagonal line. So we've got 1 here, 2 here, 3, 4, 5, 6. Okay, so I've got 6. Now this one over here, that's a bit of a part one. So we've got 6 full squares. Okay, then I'm going to start by colouring in all of the part one. So I'm going to have to try to match them up as best I can. Now it's not an accurate drawing, so I'm going to have to sort of try to approximate this as well as I possibly can. But what I'm going to start with is I'm going to look at this one over here. This is almost a full one, and I'm going to say that this one can become a full one by matching up that tiny little piece there. So that's another 1 in yellow. Alright, so I'm going to take my green now and I'm going to try to find another pair, and another pair that I can see is probably this one over here and this part one over here. So that's going to be another 1 whole square. So let's try for a different one. Let's try hang on, try to get my blue. Let's look at this one. That would probably match up really well with this one over here. So that's going to be another 1. And then we've got, final one is going to be this one and that one. So that's going to be +1. Okay, so you can see now you've got the pink whole squares. Okay, so there's 6 of those, 6 whole squares plus 1 in yellow plus 1 in green, plus 1, plus 1. So altogether, that gives us a total of 10 centimetres squared, which is equivalent to what we did mathematically using the formula. So essentially what we've done is we've taken our area of a rectangle formula and we've said length times width divided by 2 would give me the area of a triangle. Okay, but that would give us the area of a right triangle or a right angled triangle. Not all of the triangles are right triangles, and they're not all going to fit equally or evenly into rectangles and squares. Sometimes we're dealing with scalene triangles, sometimes we're dealing with equilateral triangles, isosceles. There are a whole range of triangles that don't necessarily fit equally into rectangles and squares. So this is where we have to sort of come up with a formula that's equivalent to the process that we've just seen, but has got its own formula that fits into every single type of triangle that you use it for. Alright, now I've moved up the page just to make a little bit more room so that I can show you how this is done. If I draw a triangle over here, just a standard scalene triangle, this is different to the triangle that we looked at above, but we still want to use this type of layout for our area of a triangle, because every single triangle does fit into that formula one way or another. But I'm going to add a couple of different variables to this. Now I'm going to say that instead of that being my length, I'm going to call it B, or my base. And I'm going to add another thing, and that is this over here, this height or this length here, and I'm going to call it H, and that's going to be my height. Okay. Now, rather than talking about length and width as we do when we are working out areas of rectangles and squares, I'm going to change my lettering and I'm going to now start talking about base and height. So wherever I see an L, I'm going to replace it with a B, and whenever I see a W, I'm going to replace it with a H. So what my area formula will look like now, instead of it being L times W over 2, I'm now going to say B times H over 2. And the reason why we do this is because of the things that I was talking to you about before, that our triangles are not all right triangles. They're not all going to fit exactly into our rectangles. So we need to replace them with different variables, and these are the variables that we use from now on. So if I was to take any triangle at this stage, I'm just going to draw any triangle, I'm going to suggest that my base is going to be 3 centimeters and my height is going to be 2 centimeters. It's 2 centimeters. I can now use this formula over here, and I can just enter my variables in, my base and my height, and I can say base being 3 times by my height being 2 divided by 2, and I can work out the area of that triangle. So it's going to be 6 divided by 2, and that's going to give me 3 centimeters squared. Okay, so I've shown you above how we can come up with this formula over here, but from now on, every time you want to work out, even if it's for right angled triangles, we can still use this same formula. Area of a triangle equals base times height divided by 2. So that is how we work out the area of a triangle.